to start off with. Loops and unicorns. All right, so who wants loops in the Puppet language? All right, all of you. That's why you're here, right? And some of you want unicorns too? Yes, please. Yes, where? Give us the unicorn. All right. Where's the fucking unicorns? Yes. All right. So I'm going to talk about the new parser. The new parser that's in since 3.2 that you can opt into, how to opt in and what that gives you. I'm going to talk about the new language feature in that parser and what's coming. That's just, almost there, not quite yet. And also about the new approach that we've taken with this new parser and what that means going forward. About how to opt in, experimental features that we are going to release, and how to maintain backwards compatibility going forward. All right. I'm clicking too much. New parser. The future is already here, and it's evenly distributed in all 3.2 Puppet that has gone out. So it's already there if you have Puppet 3.2. It's rewritten from the ground up. The Puppet language and the grammar had undergone a series of changes. Different people have been working on it over time, and no one thought about all the things that were in the language. And basically it was like 5 different languages in one and the same language. And it was really, really difficult when there was a bug to fix that, because then something else broke and the grammar was all over the place. And I did a lot of work on the grammar in Geppetto that supports the Puppet language and needed to support it in a different way. So for Geppetto, I had written a completely different grammar, a different implementation of the Puppet language. And then I was able to take the result or the experience of doing that back into the technology that is used in Puppet and rewrote the grammar the same way as it's done in Geppetto. So they're totally 2 different implementations, but they're similar in style. And by doing so, it was possible to remove some of the quirky grammar constraints that were totally mysterious. Why can't I just pass an array or a hash directly to a function? Why can't I dereference a function? If it returns an array, I can't immediately say just bracket 1 or 2 or something to get a value out of that. That completely blows up. Why can't I interpolate a function call? Why do I have to do all these funny extra syntax in order to get that to work? And it's completely mysterious to people why and where things break. And that was because of these idiosyncrasies in the grammar. So 2 things. Next thing, improves on error messages. Because the approach is different, it uses the approaches like in the IDE. In Geppetto, it's a very permissive grammar. It completely allows you, at the first stage when it's working, it allows pretty much anything. All right, so $A equals node 1 plus 1, blah, 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 something, right? It says, okay, I understand. You're trying to assign a node to a variable, and then this goes on. And then in the next stage, it looks at what was actually being stated in that Puppet logic. And then they can go, you can't do this, right? Node doesn't produce a value, so you can't assign that to something. And this is not a valid host name and so forth. And then it can give you much more detailed and much more interesting error messages, as you will see in a little while. And as I also said, this is the enabler for being able to opt into new experimental features and backwards compatibility. One thing I did not want to do, I want to do with a new parser to be as compatible as possible with the existing language, but I did not want to make it bug or bug compatible. Certainly the really stupid quirks. That means that there is something that if those constants are in your current Puppet manifest, when you switch to the future parser, it will come out and spank you and say, no, can't do that. There's a few things like that. But that will form like the baseline for going forward. And I'll talk a little bit more about that. How many have tried using what you can do, you can turn it on either just on the command line. Can you guys in the back see the code? You see that? Is it too small? Or too low? All right, okay. Some of the slides have stuff that goes down there. But, all right, I'll call out. I'm just checking, so if I have to read out the code out loud. But this says Puppet apply -- parser future. And that turns it on for this invocation. You can also turn it on, the parser in a setting. So I know some that have tried it on their production system just to see what happens, and I know some that are completely happy. Nothing happened, which is great. Then it did what it was supposed to do. And others have seen some errors come out, and we've also had like a dozen or so bug reports that have come in, and all those things have been fixed. So the latest release, I think it's pretty good actually. So some of the dequirks I've already mentioned. Interpolations and functions work. You can just call the function in interpolation. Now can you read this? Can you guys in the back read this? All right, okay, good. Pass literals, arrays, and hashes. And one more thing, numbers are now numbers. Which, yay! So if you want something that looks like a number but isn't really a number, then you have to quote it like it's a string. Okay. It's still a string though in the runtime. So yeah, because Puppet doesn't really have numbers. I hope to change that as we're changing more things.
An ideally perfect virtualized environment,
octal numbers,
like a data center that's completely virtual.
It'll come back and say, so this is not a valid number. It's not an octal number. Same with hex numbers. So it'll save you some things like that. It will validate those. Some other new things, and this had to be done in order to make the loops really useful for data transformations, and that is the ability to concatenate arrays. So if you have, it says $A is an array of some numbers, and $B is some other array, then $C is $A plus $B. That's concatenation, right? Now you can also append to an array. Of course, these create new arrays. It doesn't, because they are immutable, so you can't change them. So you get a new array. Do that. You can merge a hash. That's also the plus operator merges two hashes, and the one on the right wins over the one on the left if the same keys are in both. So this is also available when you turn on the future parser. Some other small things. You can do unless else. You couldn't do that before. And all right, who wants to write things like this? Us? You do, all right. Good, so we have one user. Actually, I find this really useful when you're trying to debug code. And there is an unless statement, and it looks best if it is an unless statement. But now you wonder, why didn't that happen, or did it happen, or what's happening? And I want to have a notice or something in that I'm debugging this. With an else, I can easily just attach that and then remove it or whatever. Otherwise, I would have to have reversed the entire expression, which sometimes is really painful. So I think an else on unless is quite useful. A side effect in itself, being able to say that $A is equal $B is equal to 10, and thereby setting both variable A and B to 10, might be somewhat useful, especially if you're supporting like an old API and some variables that has to be set to the same value. But what I really want to point out is that now everything is an expression. So inside of the new parser, everything like 1 plus 1 is just the same as you're saying node. It's just a matter of, is this a valid expression? Can I add 1 to a node? No, I can't, but we capture that in validation of it later. So now assignment is just an expression just like anyone else, which means that I can call a function and set a value in a variable at the same time if I like. We can also differentiate now between things like at the bottom here, you see it says $A equals $X, and then square brackets 1, 1. That is I dereference an array that contains arrays, which is very different from saying $A equals a reference and pick out 1. And that when I've done that, I would like to produce an array with the value 1 in it. Now you might say that, well, why should I be able to do that? Well, that's because everything is now an expression. So doing just an array, like square bracket 1, n square bracket, that is a result in itself. And as we come to the loops and the lambdas that support that, and I'll come to what that is in a bit, the last line of code that is executed is also the return statement or return expression. So it produces that value. Then it's just a matter of how much of all these new things that the new parser gives us that we expose in a particular language version. And that's something we have still to discuss for Puppet 4, how wild and crazy we want to go with those things. Like, should we be able to say, $A equals if, and then have an if-then-else expression? Should we allow that or not?
Yes.
Yeah, good. Then tell everyone else that you believe so, that we should do that. There's a number of such things that we then can make available in the Puppet language. Right now, those things are not turned on. You can't do that because it validates to as closely as possible to the 3.2 version of the Puppet language, so to say. Just an example of error reporting, the example I gave you earlier, Puppet apply $A equals node A plus B. The current one says error, syntax error at node on line 1. What you get with future parser is a series of errors that in much more detail tells you, the host name is wrong, you're only allowed to do this. It gives you positions on the lines. You can see it says, invalid use of expression, and no definition does not produce a value at line 1, position 6. So much better than you can just count numbers of characters in your source and then see where the problem is. So much better error messages. Not everywhere, though. Depending on how bad the problem is, even the future parser can't, digest anything and make sense out of it. So there'll still be just like syntax error, I don't know what you're talking about, kind of problems. A little bit more about I've already touched upon this, a forgiving grammar. Although you will never see just the forgiving grammar in action because there's always a validation step that happens afterwards. And it validates against a particular language version. So language version is from the point when this is the standard parser on. Language version is not necessarily the same as the Puppet version. So we will be able to support an older version of the language with a newer Puppet runtime. That is, users will benefit from this, get other benefits out of the runtime itself, but they can stay on a language and ensure that it understands that particular language version. Right now, we only have like the old and the new, but you're going to see more work in this. What are we going to call these versions, etc. Also, evaluation is separate. So we can evaluate the particular language version way. So again, language version is not necessarily the same as Puppet version going forward. We have work to do on modules. For instance, you could use a module that specifies that it is at a specific language version, even if you're running on a newer language version for other modules. So we see that as an important way for those that are writing modules do not have to all update their modules at the same time. So, new language features. Oh, I spoiled it. But writing new language features really hard. If you just go with what people tell you that they want, like it needs to walk on water, it should be able to, it should function below sub-zero temperature, it should fly, it should be fearsome, it should have night vision, you might end up with something that only a mother could like, only the implementer of it. Or you end up with something that's, kind of cute. It's kind of cute and nice and cuddly, but also kind of useless. You're really going for unicorns. And the difficulty here is, of course, we want to make things so that they work all the time. When we introduce something, we can't rewrite all of Puppet all at once. Let's change all the things. That will just take too long. So we have to make the incision somewhere, transform one part of Puppet into this amazing unicorn that we, all want it to be. So, some new language features, some of the unicorns. Starting with iteration of lambdas, and I'm going to talk briefly about Puppet bindings that just recently made it in. And I'm going to talk about two features in the language, Heredoc support and Puppet templates that are pull requests at the moment. Iteration and lambdas. So let's see, how many here, programming or dabble in Ruby? That's almost all of you, right? So how many? I'm going to ask this a positive way, or it's too shameful. How many here know what a lambda is? That was about half of those that hacked in Ruby. So all right, a lambda is a function that has no name. That's really all that is. All right. That was easy, right? So a nameless function. But since it's a nameless function, you can also pass it around. It's just like anything, another data element. Although there's restrictions on that at the moment in the Puppet language. But you can use it for the things, now for the purpose of iteration and other things, as you will see. Take the basic iteration function each here. And as you see, the syntax here is each is a function call, and we give it a variable foo, which assumably is an array or hash or something. And then the new stuff here is you see pipes, and you can think of that as like I'm piping whatever it is that each wants to pipe to the block on the right-hand side. That is the logic, which can be just an expression like notice X, or it can be a whole sequence of expressions or statements. And when I'm doing that, the thing that I'm piping through, I'm going to assign that to the variable X so that it is available inside of that block. That variable is a local variable in that block. It will not exist once you've done this. The X does not exist anymore. And it's a new X for each and every call when it's invoking this thing. And see if I can do that without falling down. The part after here, starting with the pipe and the block, that is the lambda, right? So it's a function that doesn't have a name, and it takes X as a parameter. That's really all it is. And you can have a lambda attached to any function call that is done that way. And there's a new way of doing a function call that is like an inline thing. So instead of saying each and then giving foo as an argument, you can say $foo dot each. And those two lines, this part here, is exactly the same. It's equivalent.
Why both?
Why both? You may have a function that has no argument, but you still want to invoke it with a lambda. So if I have no data, like a variable, I would need to invoke it on undef or something strange in order to make be able to use like a dot on it.
Why would you iterate over undef?
No, I wouldn't. But if I have no value on the left-hand side, should I just like do dot each? It's kind of strange. But I pass it to a function. Why do I have the dot? Well, that is to make a sequence of operations. Like first I need to filter, and then I need to transform. Just read nicely from left to right rather than be one function inside of another function as a parameter, because it's just really hard to read. So those are the base concept. There's something called a lambda that is being passed to functions, and you can do an inline call. And then we've used that to implement the various iteration or iterating functions. So we have each. The basic iterations: select and reject, like filtering; collect, which is used to transform; reduce, which is another form of transformation; and slice, just to hack something up into pieces. And I'm going to show these one by one and explain how they work. You can also write custom functions. Your own functions can take a lambda, and it's super simple if you're writing a function in Ruby to invoke the Puppet lambda. So I'm going to show that. I'm going to use toy examples with just like ABC and 1, 2, 3, just to show you the principles. Then I have one example that is more like a real use case, a slightly longer code, just to show that it works on something that is real, not just like toys. So here I have an array ABC, and I'm just iterating it over it, A each, giving each value, and I'm just noticing each value. The result is, of course, notice, scope, blah, 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 ABC. Right? I'm just iterating over it. And since you can have any expression there, you can create a resource, you can do function calls, you can create many resources, etc., etc. I can also get the index. If my lambda takes 2 parameters, index and value, I will automatically get the index 0, 1, 2, 3, 4, 5, and so forth for the array. So here my notice will naturally be 0 equals A, 1 equals B, and so forth. All right? Super simple. Sorry? And for hashes, I can iterate with key and value, naturally. So example here says A is 10, B 20, C 30, and then get the same sort of iteration. So with a hash, if I don't pass it key and value, you will get the elements, and then each element is an array of 2 slots. That makes it easy to wire this up with, like the next step would be, the next step in the transformation that you want to do. Okay. We have select and reject. Select is, pick the ones that the predicate returns true for. So the first one is, I'm just calling notice, select, the value equals 2, which of course produces then an array. You don't see that with notice though, but it's an array with a 2 in it. And notice A reject value is 2, then of course I get 1 and 3, right? You don't notice doesn't print the brackets around it, but they are really arrays that come back. Okay? If anyone wants to ask a question while I'm, feel free to just wave. All right. Go ahead.
If I'm reading this example right, it looks like it's E arrayifying on the second one where it says 1 space 3. If that was returned as an array, wouldn't that have 2 notice lines for the reject example?
No, notice turns an array into a string and does join on it without brackets. This is the actual output you get if you do notice. So I think it should print bracket 1, 3 bracket, right? But it doesn't, right? But it is an array.
It is an array, okay.
Yeah. So you can continue. Yeah, go ahead.
Maybe I missed it. Was there also a up to, down to?
No.
Type of, okay.
But you know what? You can write one. You can write a function yourself, like from to, give it 2 numbers, and then you get a lambda, and then you just inject that into, that's really easy to do. If you want that, so yes. Then we have collect, and collect is really a transformation. You use this when you have a set of values and you want each of those values to be transformed into something else. So if you transform an array 1, 2, 3 and do this, collect value, and then $v multiplied by 10, then the result is an array with 10, 20, and 30 in it, right? So collect is transform what I have into something else. And I get exactly for each element I have in my original array, I get a transformed thing in my result. Then there's reduce, which transforms all the elements into 1. All right? The same as in Ruby, right? So here, for instance, I want the sum of 1, 2, 3. I want just to sum them all. Typically, this is not what you do, of course, in a real manifest, but just to show you the principle. So what this does is it takes, and if you do not give it a start value, it will pick the first value as the start value. That will be passed as the memo, that is like the result from the last iteration. And then it will take the next value. So first call, it will get 1 and 2. And then it returns the result of 1 and 2. Then memo is the result of 1 and 2, which is 3. That's passed in as memo. And then it gets 3 as value. And then it adds 3 plus 3, which is 6. So 1, 2, 3 is 6. And then that comes as an output. What you can do with this is, of course, you can iterate over an array. You can pick elements you want. You can then collect them into a hash by using hash merge or an array concatenation. So memo is an array that you're constantly appending things to, right? So then you have a powerful way of transforming data if you need to do so. So, example. I have an array of usernames, and I want to set some RC file in their home directory. I want to set X as owner. I can do that directly, like so. I just iterate over it, and file resource, blah blah blah, something, and I'm done. I could have a hash with users and modes or whatever for some files that needs to be set. So then I iterate again over that hash and pick out the variables owner equals, mode equals, and so forth. So typically this replaces what people typically do, and that is to first have some sort of inline template that massages data and then call create resources. Now you don't need to do that. Sorry? Or define types. Or define types, yeah, to do the same thing. All right. Okay, so I want to filter first, and then I want to create resources after that. So I say select from an array here of some data. It's all fiction here, but anyway. But select that, and then I use a regular expression to filter and say I want the ones that match com somewhere in that. And then for each of those, I want to use that and set that as a unit. The owner was a pretty stupid example, but there's something wrong with that, Next one, include classes based on array of roles. I get an array from as a fact, and this is a real example. Someone was doing this, and they have an array with all the, but they have to change it so it's called role because the classes are called role something, and then they get the strings from the machines. You can do that. All right. Custom functions, Ruby. If I want to write my own from to functions, for instance, the lambda block is always passed last. So I can check, did I get one? It's always the args -1. Did I get one? Well, check if the block is a lambda. If I have that lambda, I can now call it. And I just say call. And in a function, you give it self, which is the scope, which it needs to get access to the rest of the runtime. And then just pass the arguments, whatever it is you want to pass. You can pass as many as you like. It has to match, of course, what the lambda accepts as parameters. So really, really simple to use in your custom functions. And of course, you can ask the lambda about its arity, how many parameters it has. Some of you look really suspicious, others are nodding and all right. Well, no questions on this right now? Okay.
So you can only have one lambda.
Sorry?
Only one lambda per
Only one lambda, yeah.
wait, I can remember what?
Sorry? Function call. And you can't assign, we don't have closures. So you can't say $A equals a lambda and then pass them around. The language is nowhere near ready to handle things like that in the runtime. At some point, perhaps, maybe, but not right now. You can attach one and do a function call. If you want to read more about all the details, lots of more examples and what the slice function does, or what happens if it's empty, or all the corner cases, that's described in ARM2 iteration, and there's a bunch of other examples in the second one, ARM2 examples. You can go and read. All right. I'm going to talk about Heredoc. So Heredoc, now in a pull request. I have one slide, basically. I have an example too, and then something else. So Heredoc, you're familiar with Heredoc, I suppose, from Ruby. Basically what you're saying, from this point on, or starting from the next line, the text that's there until an end tag is verbatim text. Please don't change that. So this gives this ability also to Puppet. But we changed it a little bit. There are some issues with this in Ruby, and there are certain issues in having the exact same syntax as in Ruby inside of the Puppet language. So some improvements on that. You get Heredoc by using the @ symbol, and then parentheses. One is here, and the other one is way over there. And then you give an end tag. And if you just do something like end or ends here, or end, you get verbatim text. That is, there's no escapes. Everything is exactly as you've written it. There's no interpolation. Dollar character is a dollar character. You don't have to worry about anything being interpreted in any other way than the text that you've entered. The rest of the things is about turning other things on. So if you quote, double quote, the end tag that you put here, then you get variable interpolation. If you, at the end, say slash and give a list of characters there, then you can turn on interpolation of tab, space, return, new line, dollar, or end of line. And then that means that you can insert a new line, a tab, and so forth, or a dollar, where they otherwise would be interpreted just, like verbatim. You can remove line endings with the L that way. The main intent is, of course, to use this to write scripts and stuff where typically you have dollars and slashes and backslashes and all these things, and it's just really difficult to count how many times you have to escape them. So it's a good thing that it's all turned off by default. Three other things you can do. There's a pipe that you use at the end, before the end tag, that allows you to control where the left margin is. And you will see example on the next slide. You can also trim the very last new line so that it doesn't end with a line ending, which it otherwise always does. Further, you can say colon and the name of a syntax. That will enable two things. It will enable validation of that text, given that there is a syntax validator. And it comes with two, for JSON and YAML. And it's easy to write new ones, and you can include them in Ruby code in your module. And what it does is that it will, after it has produced that text, possibly with interpolations in it, it will then give it to the syntax checker, so the syntax checker can say, yeah, this is valid JSON, or yeah, this is a valid properties file, or whatever it is, before you send it out to lots of machines and have them break a lot later. Now you get it immediately as a syntax error. This also gives tools like a Geppetto a tag to attach to, so that they can do syntax coloring and help while authoring. All right, just quickly. So an example might look like this. So $A equals at, and then end, and then the end is here. And then the pipe is used to set the left margin, so all this space here is just removed. So this line that is indented 2 spaces will be indented 2 spaces in the text string that is returned. So there's no need to, as in Ruby, you have to do like G sub and count how much you've indented the code, and then someone formats the code for you, and then it's not true anymore, and you get something completely different than what you intended. So that's pretty much Heredoc, without showing lots of different examples. Oh, I can do more than one. So if I need two, then this is the first one and this is the second one. Right? And I can place these tags wherever I want on the line. All right? The first one is not part of the second one. No. So this part here will be, this is the text for the first Heredoc, and the other one will get, this is the text for the second. All right? Basically, it has one cursor, one read cursor that ends here after it has done the first Heredoc, and the second one, continues here until here, and then it's going to continue parsing down here. All right? ARM4 describes this in more detail. All the things that happens, coordinate cases and stuff. More examples also there. You can try it out, of course, if you take that pull request and if you want to play with it. Templates, Puppet templates. This is also in a pull request. Puppet templates is the same thing as ERB, only that the syntax, the code you're writing is in Puppet DSL. All the same tags, so everything is the same. If you wanted to, you could just take the templates and just change them from .erb to .epp, change the $@ and it's used for, sorry, the at in front of a variable name, and just change that to $, and then go. And of course you can loop and do all these things because now we have loops. The new thing is that it's parameterized, so you can parameterize your templates. And I'm going to show that first. So you can declare parameters if that is the first code that you're evaluating is, here it says parentheses, $x equals, and then a default value, just like if you were declaring a function. And then you can use that variable, of course, inside of your logic. If it doesn't have a default value, you will get an error if the value was not passed. And when you're calling them, there's two new functions, one EPP template and an inline EPP template. A bit of a mouthful, but it allows you to pass a hash of parameters to the template. So you don't have to have the variables as variables in your current context. Instead, you can think of it as a function that you're calling. All right? So here's an example, calling an inline template. This is not the $x you are looking for, and then it passes x and sets it to droid in a hash. And then the output is, this is not the droid you're looking for. It did not reference the $x that was in that scope in that case, because of course the x will hide it. Now this works whether you have declared parameters or not, that you can pass in additional local variables into the template. What you get if you do declare the parameters in the template is that it checks that they are given, of course. Yes?
The question is, you said earlier on that everything is conditional or statements?
Everything is expressions, yes.
I'm wondering, can you run an exec or something like that, basically saying if, for example, I do else mod and I'm looking for a module. If this is present, say, set a variable to this.
Sure, you would call a function in that case. You can do that, of course.
Okay.
Or again, Puppet templates. There's a full ARM with all the details. I'm running out of time. I have. Yeah, and not on the agent. If you want to do things on the agent, it's types and providers you need to look at.
Yeah, or facts.
Yeah.
No, facts. Yeah. I have. There's a party after this, so feel free to, if you enjoy beer more than talk, and if you want to ask questions, I'm going to stay here and I'm going to show these things, and you can ask as many questions as you like. I have 3 slides on on Puppet bindings, and then this is over. So we have Puppet binder that has just gone in, and you can turn on the binder either by using the future parser, which uses it, or if you just want to use the bindings and experiment with those. So what is this? It's more powerful data bindings. We use it for both data, like Hira type data, but also for Puppet extensions, like the syntax checker thing that's done via these extensions. What it does is that it composes the new Hira 2 data that you can have in modules. And you can have them in modules or in your environment, or your conf dir. And it also composes that with Hira 1, if you have existing Hira 1 data. You can do bindings in Ruby, and you opt in on the command line or with settings. So what happens when you do this? Well, the default is if you opt in, you will get all Hira 2 data that it discovers in the default location, specified what the default is, and all the default Ruby bindings, also specified where they're supposed to be, from all the modules on your module path. It will compose all of those, and it will also do the site level Hira 2 data and Ruby bindings, and if they are present, they will override anything that anyone contributed from any module. So that's what you get by default. All the data will just be composed. If there are errors, if there are conflicts, 2 modules have an opinion about what Apache port should be, and it's different. Even if it's the same, it's still an error actually. It will say, you can't do that. We can't have it 2 ways. You have to resolve that by, and then fixing it at the higher level. All of this is totally customizable, so you can change how many levels you want. You can introduce more levels in the hierarchy, etc. Place things in different locations and provide alternatives, and lots of options here for large complex systems. What's different in Hira 2? Hira 2 is composable, and that's the main difference. Hira 1 is like, it's just one hierarchy, and it's in one place, and it's quite static. You can't even have like different Hira instances up for different environments. It's just one. And it just didn't work to try to use exactly the same type of configuration when doing it and having modules that you compose. Since we had to change things, we thought we wanted to correct also some other things. And that is the interpolation. In Hira 1, it uses % and brackets, curly brackets. Now, what you interpolate is Puppet. So it's a Puppet DSL. And you can have any Puppet DSL expression in there. So you can interpolate variables, you can do function calls, you can have a loop, a unicorn, your ugly, thing with duck feet, whatever, knock yourself out. We also changed the Hira YAML syntax for version 2. There are some differences that one needs to observe when using this. However, it's really easy to opt in. This is the minimal Hira YAML you need to have in your module in order to make it participate. You need to say -- and version 2. That's it. Then you get the defaults that I was talking about earlier. And then you stick the data, common data in data/common YAML. And this works just as before, with the exception of the interpolation. And you get OS family also by default. Because we think that the typical things that you will contribute in modules are common bindings, that is global bindings, the defaults, and for OS families. You don't really know about environments or any specifics about nodes. So this seemed like a reasonable default. If you want something else, fine, you can contribute bindings for an environment or nodes, etc., if you have modules that are specific to your organization and your environments. Totally doable. You can read all about it, more than you want to know, in ARM 8. And that's all the background. And ARM 9 is an implementation of what's described in ARM 8 for data in modules. So it's not all of the things in ARM 8. There's a lot of examples there, and it shows how to use the Ruby bindings, which I'm now 5 minutes over time, so clearly I did not have time to talk about that. Just to conclude, we're getting there, you know. All right, thank you.